Hey guys, welcome to this tutorial. Basically, what we're going to try and do here is set up somewhat of a CI/CD pipeline for easier development and deployment of Lambdas using the container feature that Lambda offers. This is something I personally have struggled with in the past, and this is just one of the ways in which you can implement a CI/CD with Lambdas. There are other ways that you're free to explore, but this is something that I've seen that has worked well in production for me, and just passing on that knowledge. This is somewhat of an ad hoc tutorial. There's not a lot of preparation done for it, so there would be a bit of back and forth. I'll try to, if I get stuck, I'll try to kind of explore. But other than that, I think I think you'll be able to kind of implement it in your for your own use cases. So before we start off, just a bit of overview when we talk of lambdas. So I think if you're not aware, obviously this is not a in-depth tutorial about how lambdas function and what is serverless compute. But in general, AWS offers the earlier way of using lambdas was something that you can give a function name, and let us just try to create a test function. Here I can use kind of any runtime environment. I prefer to code in Python with lambdas. It's just simpler, and if you create a function, what you'll see is you'll be able to kind of edit the function right there on the console. Although this is extremely efficient for smaller functions, we run into issues when there are multiple people working on the same code base, and when you want to implement something a bit more complex, editing it right here in the browser UI is not something that is very comfortable. Although they've done a pretty good job, but I don't think it's the most intuitive way to go about it. At the same time, I think adding dependencies in this kind of a mode is a pain. You need to use something that Lambda calls as a Lambda layer, which I feel is very non-intuitive because it's just a pain working with layers and building, and you inevitably have to end up building custom layers. So I won't get into much depth on how this kind of a package Lambda works. This is something you can check out. What we will be doing alternatively is we will be using the container image feature. So basically it deploys an image as a running container behind the Lambda infrastructure, and kind of uses its scalability and other factors to kind of deploy your container. I'll show you a few advantages of that as we work through the tutorial, but I just wanted to differentiate what we're gonna use here. And we will also be I'll be showing you how you can actually code in VS Code, and then of course merge it as a container image. You can use VS Code even to author a Lambda, which is a zip package, as this first option gives you. But it is largely not very well defined as a process, so we will be following the container image. So let's get started. Let me give you a brief overview of what the broad steps are. The first step is we will be creating a repository with a folder structure. There will be some things that are specific to a container Lambda structure that AWS requires to run, especially in the Docker file. By the way, if you're not aware of Docker, I would suggest you read up a bit about it. You won't need it for this tutorial, but it would definitely help you to work with containers in the future. So the first step would be creating the repository and the base folder structure. We will be creating a starter image, kind of like an ad hoc way of creating. Of course, you can make a script for it, but we'll just be creating an ad hoc image, pushing it to AWS in their ECR, which is the container registry, similar to a Docker Hub. The reason we have to create the starter image is that when you create a Lambda using a container image, you will have to provide a starting image URI. So that is why that is required. Then we will be creating the Lambda with that starter image. We will be also setting up Lambda aliases and versions. I'll show you how that is one of, I feel, the more efficient ways of managing versions for Lambdas and not ensuring that any merge is breaking your running Lambda code or a stable Lambda code. Then we will be setting up the CI/CD pipeline where as soon as you merge a feature into your core Lambda, like the underlying Lambda code, it gets deployed. And we will also be kind of covering how you can run a test on that Lambda and see that everything is working fine. The testing part of it will be pretty simple. We will not be doing extensive automated testing. We'll just be testing it right there on the console. So let's get started. The first step, which is creating a repository and the base folder structure. So as I said, this is an ad hoc video. I have not set up the AWS account. I have not set up the GitHub repository. So everything will be from scratch, and hopefully it will give you a good way to follow along, because in case you are starting from scratch, this would work out well. So let us create a repository. So a good way with whenever we're creating a Lambda repository is that Lambdas are a short piece of code. So it's not gonna warrant an entire repository just for one Lambda. So what I usually like to do is create one repository that will house all the Lambda code. This of course is easier if you write your Lambdas in one language. It just makes life easier. However, you can of course have different kind of implement your Lambdas in different languages. And then inside that Lambda, you can have inside that repository, you can have different branches per Lambda. In fact, I would say you can have 2 branches per Lambda, where one branch is deployed on your dev environment and one branch in your production environment. If you have more environments, you can have more branches. This is a good way to handle it. Of course, you can keep separate repositories for different Lambdas if you really want that. So let's just call it something like container Lambdas, and we don't need this. Add a readme. Get ignore can be, I'll be implementing it in Python, so we can add a get ignore that's in Python. This is public. Okay, yeah, I think we can create this. So I won't be creating different branches for this. We will just be using the main branch just to keep things simple. Of course, as I mentioned, you can create branches based on different Lambdas. Let's clone this repository. Perfect. So this is of course a base project. We need to create folders. So the first thing we can do is just create an app folder. Inside that, you can just add app.py. You can create any kind of folder structure that you want. I'm just showing you as a sample. Here, if you see, what we can do is we will need a few things. 1 second. We need the Docker file, and we will also need a 1 second. I'll just create it. Inside, we will need a requirements.txt file. This is typical with Python projects. You can, depending upon which runtime you want to use for your Lambdas, you can have a different. You can follow the same way that Lambdas in that runtime how you attach dependencies. So in Python, it would be typically a requirements.txt file, and we will also need a build config.js. actually it's a build spec.yml. So this is something that AWS uses to kind of understand how to build the project. We'll just see that once we implement the CI/CD how this file is being used. So I have the code written here. So let me just quickly paste it. I will just explain the code once so that perfect. So what we're doing here is from the Docker file we're fetching the base image as the 3.10 Python image. We are adding the requirements.txt file to it. As I mentioned when I was giving the introduction, that layers is a very difficult way I feel to manage dependencies, but adding the ability to add the requirements.txt here means that you'll be able to work with whatever SDKs you want in a very intuitive manner, which is just doing a pip install and freezing it into your requirements.txt file. So it copies it there, and then this code basically runs it to install the dependencies into the container. Once it's running, you add the app folder into your Lambda task root, which makes it accessible to be run. And then finally what needs to be run is what you're seeing here in line 9, which is app.handler, which is the name of this file and the name of the function inside it. So you can obviously name it anything you want and this file as anything you want. Just you need to remember that whatever you name here and the handler is what you're using inside inside your Docker file here. So, and build spec, I will share this build spec file. This repository will be available to you at the end of this tutorial, so you can just read through it. I won't get into very on the high level. What it essentially does is it builds the Docker image and then it allocates the Lambdas alias to the Docker image. I will explain it once we actually run the CI/CD build. That will give a better picture. But till this point, I think understanding how the Docker file is structured and how app.py is structured as a base Python code or a function implementation is important. So we have set this up. So what we can do is we can do something that's really anti-pattern, which is directly committing to main. But I think we can do that. All of that looks important to be committed. Fine, get commit. Let's push this. Okay, I'm getting permission denied because I am connected to GitHub through another account. I'll just fix that. So I generated my access token and I've been able to push it. So I think here I'll be able to show you. One second. Main branch should have this structure, so as expected all of that is in place. So we have completed the first step where we have created the repository with the base structure and the Docker file. Now we have to create the starter image. Now for the starter image we need to first create an ECR or a container registry. So let's just go over. Here repository, we can call it tutorials slash, I think I gave it a name here, container lambdas. So this is very similar to how Docker Hub works. You just have creating a repository where, or a registry where you can push your images to. Just fine. We'll just create one. I think this one. So this name you need. You'll be needing it later on, but for now, this is what you've created. I think what we will need to do is we will have to build an image. Okay, so we are already in the kind of parent folder, so we will just need to forgotten to start Docker my machine, so just starting it up. Perfect. So the Docker engine is up and running. Cool. So now I think we should be able to build this. So it's built, and we will be pushing I think there are issues with the auth, so just give me 1 second. So basically, to log in, basically on the terminal, what you need to do is run something like this, where you will get login password profile tutorial. So what profile means here is that on your machine you will be having AWS credentials. This is where you will be setting up your profiles. To check more about this, you can check out how to set up credentials on your machine for AWS CLI access. So that is something you can check out separately in the AWS docs. And once you're logged into Docker, you'll be able to push this container image. So what we have been doing here is to kind of set up the starter image. So let us check out under ECR if that starter image has come in. So as you can see, the starter image has been registered, and now we can move on to the next step, which is actually creating the Lambda with that starter image. So we will go back to Lambda. Creating a function. Here we will be selecting the container image, and under container image what we will do is give it a name. Let's say first function under this we have the starter option. And we will create the function. So if you remember, in the starter code we simply had a code that will print this is a test and return with this kind of a payload, hello world payload. So once this is deployed, so as we can see here, when we click on test, it should actually print that and give a response payload. So this is like a sample JSON that you can use to test, but it will not be really used within the function. If you need to use this payload, that is something you can read up separately, but basically that is part of this event object that comes in. So it has successfully created the function. So now if we just do a normal test, you see the execution output, you will notice that this is the output that has come and this is a test has been printed. So we know that the function that we have developed, the image that we have pushed, that is all working well as a container Lambda. Now comes the next part where we will be setting up the Lambda aliases and the versions. So what does this mean? Basically, whenever a new Lambda code is deployed, you will notice that here there is an image URI that comes in, right? So right now your Lambda code really is running this particular image as a container. A good way to go about version control is that creating kind of two Lambdas. That is usually how I go about, two aliases, how I go about stuff. One is, you can call it as stable, production, whatever you want, and this should ideally be the version 1. So for now I will just point both to latest. What does latest mean? Latest just means the current active code. So the latest code, if once we implement the CI/CD and pipeline and any code merge gets deployed, that immediately latest is the one that is immediately pointing to it. Similarly, let's just create one more alias, which will be dev, and that is also point to latest for now. So right now what we have for this first function Lambda, we have two aliases, one is dev, one is stable, both pointing to the latest version of the code initially. So let's keep it like this for the time being. You'll understand once we actually deploy the CI/CD pipeline how this changes. So now we need to set up GitHub and AWS code pipeline. So I believe we can just check out connect to GitHub, AWS. Let's check it out. We have to head to connections. Create connection. GitHub. I believe we have to install a new app. Okay. I think we can give access to all repositories. Okay, let's connect. Basically what we'll be able to do is access our branches for our CI/CD pipeline right here. Okay, seems to be done. Now we can head off to AWS code pipeline. Now we need to create a pipeline here. I'll just be running through, just giving random names, but a good way to go about this would be to establish some sort of a naming convention within your team. So let us us move forward. Source provider GitHub version 2. Here we will be seeing the connection, and under repository name we will see the repository we just created, container lambdas, and the branch which is main. Make sure this is checked so that there is continuous deployment. We go to the next step. Now build provider, you can use Jenkins if you're comfortable with Jenkins. It would be a good way to kind of be kind of infrastructure independent in a way. For now we'll be using code build. It's just much better integrated with AWS. We do not have a code build project for this, so we will create project which we can do inline. Project name, let's just call it first function build. Now here just pick these base settings that I'm picking here. You can experiment with it won't make much of a difference. Just ensure this privilege flag is ticked, because we will need this for building our Docker images, otherwise the build process will fail. Two more things here. One is under environment, you will be seeing the ability to configure environment variables. Now this is important. This is where the build spec file comes into the picture. So if you notice our build spec file, we are looking at two environment variables. One is ECR account base, so let's put it here, and the other one we are looking at is the Lambda name. I'll just explain what is happening here, but ECR account base is obviously the registry base that we have, which is this one. I think we are adding tutorials and Lambdas, so it is only till this much. So this will help the build spec really point to the right repository from where the image needs to be taken. The Lambda name points to the Lambda to which the build image needs to, which Lambda needs to be pointed to the build image. So these are the two main inputs. So right now the Lambda name here is nothing but first function. This way you can keep this base build spec file the same for all Lambdas that you decide to build through this workflow. Arguably you can also kind of hard code the ECR account base, but where you will struggle with this is probably when you have different environments, different repositories for prod and dev and staging. So it's always a good idea to keep this kind of abstracted from the underlying code base. So these two environment variables are configured. We are good to go. Continue to code pipeline. Perfect. Build project is created. Next. Now, interestingly here, in a normal project, you will have a deploy stage. But by nature of how we have built the build spec file, your deployment is kind of happening at the point where the Lambda starts pointing to the latest code. So we don't need a deploy stage through our code pipeline. I'll show you how you will point your aliases, kind of play along with your aliases to have a stable kind of deployment process here, which can be a bit manual. So which is kind of a safer way to approach it. So right now we can skip the deploy stage. Cool, so we are all set. One interesting thing to note here is do not click on create pipeline right now. The reason is our build project needs to be given certain privileges to work with ECR Lambda, because it will be kind of making changes to where the Lambda points, right? And as well, we need to, I believe, assign an IAM pass role condition as part of the internal workings of it. So let us, we need to make that change here to the role, the service role that the build project uses before we run the code. We did not run the code immediately here. Create pipeline is the moment we create the pipeline, it will start pulling from the main branch and start deploying, kind of start building the code. So before that, let's give it access. So ideally you should create a policy with it, but right now for the ease of this tutorial is just creating an inline policy. For now, let us just give it all Lambda actions, and we can give it all ECR actions, and we can give it IM. Just ensure that in the future you only give it Lambda access to only the for your production environments, only the one that it needs. So IM, and we have pass role, I believe, yeah. Okay, so let's move. Okay, cool. Now we can run the pipeline. The moment you create the pipeline, it will attempt to pull the code from GitHub and redeploy it. So just notice that in the Lambda here, we are pointing to this image. This should change. So even in the function overview, this was last modified 12 minutes ago, and right now we're running the build. So this, you should be seeing that the modification happened. This ends with 6251, so let's just observe what happens once the pipeline finishes. It has failed. Let me just quickly retry. Sometimes issue is with running it immediately after giving it access. So it's just succeeded. So if it fails the first time, just make it run again. Sometimes it causes an issue when trying to fetch it when you just kind of deploy it. I'll pause the video for some time till this build process completes, and then I'll show you how the Lambda is behaving. So one of the issues that just happened was when we were creating this inline policy, we hadn't selected the star option for this. Point to be noted, reiterating this, in production, please do not use star. Use the specific resource that you want to point to. So ECR, it will be the repository name. Lambda, it will be the name of the Lambda, that the specific Lambda ARN that we are pointing to. In the interest of time, I've just used star. So because of this were not added, the build process had failed. So I'll be retrying this. So it succeeded now. Just one small change was that I had to re-add the build spec.yml. Somehow it wasn't committed before. So now that it has added, this has succeeded. We will be able to see it was modified 28 minutes ago. I'll refresh this. It should show that it's modified pretty recently, 1 minute ago, and we'll see that it's pointing to first function latest. Now how did it come as latest? That if you read the build spec.yml, you'll be able to kind of figure it out. So now it's pointing to the new image URI. The interesting part is, why don't we do this? Let us publish a new version. So when you publish a version, you can actually point. So version in a Lambda is a specific snapshot of the code that cannot be changed after after you create that version. So all the configurations, the environment variables, etc., that you have, you had at latest at that time when you created the version, gets kind of Lambda creates a snapshot of that entire system as one version. And the interesting thing is, aliases give you the ability to kind of point something, point one of the aliases, edit it and point it to a version. Okay, so with the setup that you see here now, stable points to version 1, which we have just created. Dev points to the latest. So now we have completed the overall setup. Now what does this mean? This means that now, let's say I go to my code, right? This is our code. And I make a change here, right? So you have the capability to print, this is a test 2. Once you've done that, you have the full capabilities of your VS Code editor. You can have GitHub Copilot, etc., assisting you in creating this Lambda. You can add your dependencies to requirements.txt as we have discussed. So let us in fact create a feature branch like you would when you were trying to kind of add a feature. So comments, oh gosh, let's just create an extra branch. So now we have added here a log statement. Done. So now I will be pushing it. Perfect. So now we have pushed this change. At this point, there will be the pipeline will not be running because there's no change to the main branch. That is what we are tracking. Now, here what you will see is that let us go into the container Lambda. Let us go to pull requests. We're creating a new pull request and you will be merging this pull request. The moment you merge it, your pipeline will automatically start because there's a source code change. So this is how you can continuously kind of implement and deploy. We'll just resume this tutorial once this first run ends, and I will show you how the aliases behave and how you can release a new version. So the build is successful, and again our function will now start. It will show last modified in 1 minute ago. And now the interesting part is you can test out, you can see how the changes are. So if I go to stable, which was pointing to the version 1 that we had released before, and we test this, we will notice that it is still printing this is a test because it is printing version 1. But if we go to our alias dev, which points to the latest version of the Lambda code, and we test this, we will notice that our changes are visible here. This is the test 2. So this extra log statement got printed. So as you can see, what you can do is when you are, let's say, your dev environment, or if you have some sort of a staging environment, if this is production, then your staging code can invoke this Lambda function with the alias dev. Of course, you can check out how you can do that. And once you're happy with how the staging or the dev Lambda is behaving through your CI/CD pipeline, what has been deployed, all you need to do now is take an action where you release and publish a new version. Now you have a version 2, which is your latest code, and you need to point the stable alias to that new version, so that now whatever your stable code is, whatever that points to the new version. So now if you go to your stable alias and you click on test, you will notice that you're getting that extra log statement. So this is how you implement. So now what essentially has happened is you can go ahead and your team can continue making changes here, raising PRs, merging those PRs, and they will start reflecting it against the dev alias or the latest alias, and you can test it out. If you feel that everything is stable, flows are working well, release a version, point your stable or production version, whatever alias that you have, to that version, and your rest of the flows automatically get kind of, because ideally all your other flows should be pointing to the stable, the production flows should be pointing to the stable alias, and they will start now kind of processing your Lambda invocations using the new version. So this is how you set up a CI/CD pipeline using a container Lambda. Hopefully this was helpful, and if you have any questions, just feel free to drop an email to me, and I'll be happy to respond. Cool. Have a good day, guys.